In this video, we're going to continue on with the calculations for our analysis of variance. We'll go over how to calculate degrees of freedom, our mean squared value, and our F ratio. So first, we're going to talk about how to partition our degrees of freedom. So for our total degrees of freedom, we need to know our big N, and our big N for the example, so please continue to follow along with that. Our big N was 15. If you're wondering where these values are coming from, you can go back to the previous video, look back in the lecture notes. They're all in there when we calculated our sum of square deviations for total, within, and between. That's the example that we're going with. So our formula for degrees of freedom total is n minus 1. If we know that big N is 15, and remember big N is the total number of scores or participants in our experiment, minus 1, it's going to give us a value of 14. Now degrees of freedom within, we need to know K. So going back, looking at the number of treatments we had in that example, K was 3. So within treatments degrees of freedom, we take N, which is 15, the total number of participants in our experiment, and we subtract K, which is 3. So we had 3 treatments. That's going to give us 12. Now to do our between treatments degrees of freedom, we take K, which is the number of groups, and we subtract 1. So we know that we had 3 treatment groups, we subtract 1, and for analysis of variance with 3 levels, we're going to have a between degrees of freedom of 2. Next, we're going to calculate our mean squared values. So we did our sum of squared deviations in the previous video. You can go back and look through the lecture notes if you want to review that yourself. Now we need to get the mean of square deviations. So this is like calculating that variance again. Okay, so remember when we calculated variance previously, we used the sum of square deviations over our degrees of freedom. So these are the formulas. So the mean of square deviations between subjects is SS between over degrees of freedom between. Within, the MS within is our sum of square deviations within over our degrees of freedom within. So again, even though they're new formulas and there's more, they really are very similar in structure to previous calculations that we've done. So if you kind of understand what those calculations are looking for, it's easy to understand what you need to do here. And then our final formula is going to be the F ratio. So the F ratio looks at, again, this MS between and this MS within. So here's that example from the previous video. And first what we're going to do is calculate our MS between. So we need our sum of squared deviations from between. And that's our value here. We need our degrees of freedom from between. And we said degrees of freedom from between with K minus 1. We know we have K up here of 3, which was 2. So to do this formula, we take our SS between, which was 30. We put it over 2, and the value ends up being 15. Now we're going to calculate the mean squared for within. So again, we need our sum of square deviations from within, and that's this value here. And again, if you're wondering where did these values come from, we calculated them in the previous video when we calculated the sum of square deviations. You could look back in the lecture notes or refer back to that video for more information. We also need our degrees of freedom for within. So we said our degrees of freedom within is our big N minus K. So look up here, we know a big N is 15. Is 3, gives us 12. So we plug these things into the formula, 16 over 12, and if we calculate that out, we get 1.33. So next is our F ratio. So we had, a mean squared between subjects of 15. We had a mean squared within is 1.33. So we take the F ratio and we put the mean squared within subject, or between subjects, sorry, in the numerator. Our mean squared for within subjects in the denominator. That's going to give us a value of 11.27. So this F value, when we're looking at this value, it's basically indicating that the difference between treatments is 11 times bigger than what would be expected if there was no treatment effect at all. So that's a pretty big treatment effect.